We're tasked with finding the arcsin of the square root of 1 minus 0.3x squared. Now the way we go about solving this is by first realizing that we need to use the derivative of arcsin along with the chain rule. Now the derivative of arcsin, I'll write f of x is equal to arcsin. I'll write it as sine inverse of u. The f prime is equal to 1 over the square root of 1 minus u squared times the derivative of u with respect to x. This term is from the chain rule, and u in the question is this square root, and so we can begin solving the question. Y prime is equal to, we'll write 1 minus the square root of 1 minus u squared. U is this green, is a highlighted green term here, so I will write the square root of 1 minus 0.3x squared, but it's u squared, so I'll put the whole thing in a square bracket. But we're not done yet. We have to also use a chain rule and derivate u. So for now I'm just going to write it as d by dx of 1 minus 0.3x squared, and instead of using the square root symbol, I'm going to write it as to the half power. And now let's derivate just this part. So while not forgetting this section as well. So I'll just hold it here. The derivative of 1 minus 0.3x squared raised to half, or square rooted. How do we do this? Well, you may notice that because it's raised to half, we'd have to use the power rule. But because there's a function inside, namely x squared, we'd have to use a chain rule again. So this is what we do. We will first write 1 minus 0.3x squared, and now we use a power rule, so we subtract 1 from the power and write the initial half as a fraction outside. And now we have to multiply this using chain rule with the derivative of what was inside the bracket, and the derivative of 1 minus 0.3x squared is minus 0.3 times 2 times x. And now we can put this term, these two terms, back with the original question. So now I'm going to write the whole thing in full. Y prime is equal to 1 minus the square root of 1 minus, here we're squaring a square root, so it cancels out. So I can just write 1 minus 0.3x squared, and then we can write this term times half 1 minus 0.3x squared raised to half minus 1 gets you negative half, and then you multiply that by this term, and that'll be negative 0.3 times 2x. Now we can cancel out the 2 with this 2, and we can also simplify this part, this term. Alright, let's see what that gives us. So y prime is equal to, I will write this section in the numerator, and I'll make this one big fraction. I'll write negative 0.3 x, the x is still here, over the square root of, now it's 1 minus 1, which is 0, but this minus is getting multiplied with this negative term, and so that becomes 0.3 x squared becomes positive. I'll make this square root smaller. And then we have this purple term. Now, what does negative half mean? The negative as a power just means you take the reciprocal of the term. And so from the numerator, it goes in the denominator. So I will write 1 minus 0.3 x squared. And the half means you take the square root of it. Square root. And now with this, now we're getting somewhere. With this we can simplify it even further. You may remember root laws with square roots, that the square root of a times the square root of b is equal to the square root of a times b, where a and b could be anything. And here a relates to this and b relates to this. And so we can write it out as y prime is equal to, I will write negative 0.3 on top. Nothing changes to that yet. I will write a big square root. Now we just have to multiply 0.3 x squared times 1 minus 0.3 x squared. This gives us 0.3 x squared times 1 gives you 0.3 x squared, and 0.3 x squared times 0.3 x squared times negative 0.3 x squared gives you negative 0.3 squared x to the 4th power. And let's not forget this square root. And now we have a second occurrence of the square root laws. Oh, sorry, I take that back. That'll come soon. I want to simplify this further, and looking at the equation, I may want to bring the numerator inside the square root. Now, how do we do that? Now, because a square root, the opposite of a square root is to square the term. So I'm just going to square 0.3x and then square root it. Now this is still equal to 0.3x, negative 0.3x. Nothing really changes. I should remove this negative to the outside. Nothing changes here. It's still the same thing. But in this way, I can bring this term inside the square root. So this is what I'm going to do. I'll put the negative outside. I will write 0.3 squared x squared. That's just 0.3 x squared. I'll put the square root. And then for the denominator, I'll write the same thing, 0.3 x squared minus 0.3 3 squared x raised to 4. This is equal to, and now we use the second root laws I was talking about earlier. The square root of a divided by the square root of b is equal to the square root of a divided by b, where a is this and b is this. So alright, I'll put the negative outside. I will write this in blue. Negative 0.3 squared x squared, and the denominator is 0.3 x squared minus 0.3 squared x raised to 4. Can we simplify it further? You can see a lot of 0.3s and x's, and that's why I didn't square 0.3, I just wrote 0.3 to the power of 2 so we can see that. And now we can simplify it further by reducing that fraction. So it's negative the square root, I'll keep some color consistency. Oh no. Oh well. I guess it doesn't want to change. Oh, never mind. Oh, we lost the blue. So I can, in the numerator, I can remove 0.3 and x squared, because that's common in all these terms. In this term is 0.3 and x squared. Here 0.3, 0.3, and x squared is the lowest out of all the three terms. And so I'll write 0.3 x squared. And I'll write what's inside. I'll write in purple. Negative 0. Right. This negative should be removed. My mistake. I'll write 0.3, or just 0.3. And the denominator, I'll remove 0.3 x squared again. And then I'll write 1 minus 0.3 x squared. Because if you multiply these two, you'd get this term. And so now I can cancel out 0.3 x squared in the numerator and denominator, and then I can write the rest. Negative the square root of 0.3 over 1 minus 0.3 x squared. And we can't simplify further, and hence we have arrived at our answer.